Right, over here I have a C-Class Mercedes and this handle has broken off. This is not the first time it's broken, and I've decided I'm not replacing this with another original handle. I'm going to weld this, and I'm going to be demonstrating how to perform plastic welding, which means that I'm going to be using heat to melt the one surface onto the other surface to reform the join. Now, you could use super glue and it would hold it in place superficially. For example, if I super glue it like that, it would hold. But super glue is brittle. It forms a brittle bond. So the minute this has a slight angle, it will just break off. Now you might be wondering, what about using these filings? The filings can be put here, build up the section here, and then glue it with the filings. Well, yes, that does work when there isn't movement. This is a car door handle on the inside, and it has significant pulling pressure. Now, yes, using the Q-bond or the alternatives with the filings that you normally pour on would hold, but again, this forms a brittle bond. So if you knock it or pull at a slight angle, you probably will just tear it and it will break off. So in this video, I will be showing the plastic welding. Now, the first step, believe it or not, is to use super glue. And the super glue is just to hold it in place while I do the plastic welding. So I just put super glue on the one side and a little bit on the other side here. Right, so I'm going to let this dry for 10 minutes. Right, so the super glue is dried, and now what I need to do is I need to take my soldering iron and I need to melt the two surfaces together to such a degree that it becomes one piece. Now, I will also need some additional plastic because over here you might notice that it's missing a piece. So I get something which I call donor plastic. Try use a good quality plastic. Over here I've got a cable tie, but over here I've got plastic from a camera fitting which is really good quality. And what I do is I melt a little bit off that and then let it cook on the soldering iron, and then I melt it into the existing plastic, and that is the process. Now, obviously we want to match the color, but for explanation purposes, I'm going to use the white to show you what I mean by mixing it together or melting it together. It must change color. The other thing is, in this installation, this is going to be covered. Notice how it's going to have this cover on, so we won't see the white. If I put white over here, we won't see it. Also at the bottom here, this is the underside, it will not be seen. So I'm going to use a little bit of white plastic just for explanation purposes so you can see what I mean when I mix it. It'll also show itself nicely in the video. Right, so the first thing I'm going to do is build up at the bottom here. Now, when doing plastic welding, you always have to check what the item is going to fit into. Is there space over here on the car to build this up? For example, if it's got a snug fitting, maybe the plastic welding will stop this from fitting in. Now, I've already checked on the vehicle and there's a lot of space around here to build this up. So I'm going to use that to my advantage and build this up with the plastic welding. Right, using my soldering iron, I've set it higher than normal, so it is over 400 degrees centigrade. I've got an old soldering bit. I don't mind if this gets damaged. It will get a lot of burnt plastic on it, and it does tend to degrade the bit, so try use one of your old soldering bits if you've got one. You can also use flux to tin and clean the bit, or you can even sand it. Now, as I said, I'm going to be using what I call donor plastic, so I'm going to cut some of this white plastic. This is a high quality plastic. I'm just cutting some off and then I'm going to melt it. Right, so I'm taking my soldering iron and just melting through that plastic. Right, so there is the plastic on my soldering iron, and I'm going to deposit it over here on the side. So it's like I'm painting it. Now, this is not enough to form a plastic weld. I'm just putting it on there and then I will melt it into the existing plastic of the handle. Right, now it's time to hold the soldering iron in such a way that it goes into the existing plastic. And then notice how I'm swirling this. What I'm doing is I'm mixing the existing plastic into the white plastic, and notice the color change. And that is why I'm using the white, to show you that it's not just putting it on top. Digging into the existing plastic and letting this white plastic melt into the black plastic. Notice how there's been a color change. It's really mixed the two together. When performing the plastic welding, just make sure you're in a well ventilated room. You don't want to be breathing in the fumes. Now, every now and then, I take my soldering iron and I poke it and then I try and fill that hole where I poked it with the plastic while it's very hot. And then I poke it into the other side, and then I fill inside there with the plastic. Remember that this is on the underside, we will not see this. Notice how that plastic is grey. It's mixed the black and the white together. Now here's a corner. It's quite a lot of space here, so I can dig the soldering iron in here quite deeply and really get that white plastic in there, mixing it together with the black plastic. Nice attachment point there. And I go right up the shaft here. I'm flexing it. Notice how it's able to bend, and that's what I want. I don't want it to be brittle. This will flex a little bit when it's being pulled by the driver, and that type of flexibility will stop it from cracking. Yes, it's still hot, so it will move a little bit more. As I put more of the plastic, it won't move, but being able to move even a millimeter will stop it from cracking. If I was using the filings or just the super glue, a millimeter of flexion would break the whole bond, and that is why I'm doing the plastic welding. Now, I don't want the white to show through here, so what I'm going to do is I'm just going to cut this part away. Right, now something that makes plastic welding extra strong is to add some rigid material. Over here I have some wire, and you can get creative. I mean, you can use staples. Because this corner here is available to me, I'm going to poke through, let this wire come right through, and I'm going to weld the wire into the side. Now, you could use a drill bit, or you could just use your soldering iron and poke through there. So in my case, I'm just going to use a little drill, and I'm going to drill through there so that I can get my wire in there. There it comes, just a small little hole, and here I'm just going to feed this wire through here. So on this side I'm just going to bend it so it can't go through that little hole. Right, so there you can see the wire is held in place there, and I'm just making sure that the cover can still get on, which it can. Right, since this part is all hidden and I'm not worried about the size, I can now let this wire go into a little hole here. And what I've done is I've heated up the wire and it's melted into the plastic here. Now the key to plastic welding is patience. It takes time to melt the plastic. Right, so if this wants to crack, it will pull on that wire. Now I'm just going to be using some black plastic over here. And this is the plastic from a cable tie. It's not as good quality as the white plastic. But the reason I'm using it is I'm just forming a little platform there. Right, now don't worry about it if it's rough. You can easily sand down the plastic, and if there's little bits, you can easily cut off the plastic. The aim here is to make it strong. Now, for a good plastic weld, you want to have the welding on the one side as well as the other side. Now, the only problem is the cover for this handle has this piece here, and it goes inside. What about just cutting this away and then allowing me the space to do some really decent welding there? Now, this tube over here is not that important because it's got this guide over here. It already fits in place, so I don't need this extended tube here, and I can also use this plastic for my welding. So what I'm going to do is I'm actually going to cut this off. Now, a nice thing about the plastic welding is you can use the soldering iron to remove the plastic you don't want. So there I'm just removing this piece here because it's not necessary in this repair, and I can just cut what I don't want away. So having a look at that now, I've removed that tube, and there you can see it will seat perfectly. That'll now give me the space to weld on the inside. Now the next question is there anything that is going to be put here that is going to be blocked by welding? Now there is a screw that's going in here, but the screw head is much smaller than this hole. So I've got all the space here to now weld, and that will make this much stronger because I'm now welding both sides. So the first thing I do is I just poke my soldering iron there. I just poke it into the plastic, and there you can see I've made quite a groove, and then I do another one like that, and now I can start melting the plastics together. Now at this point you can also add extra plastic. If you want to do the donor plastic over here, then it'll make it even stronger. So I am going to take some of this donor plastic over here. Now in that groove that I've made, I'm putting the donor plastic inside there. So I made that quite a deep groove, but not deep enough that it comes out the other side. And now I'm putting the donor plastic into the groove and then also into the second groove that I made. And another trick is to let the plastic have quite a large surface area, but it doesn't help to smear the plastic all the way here unless it is completely melted into the plastic underneath. So this is useless. If I just show you, this smear over here might seem like it's strong, but you'll see that it will be able to just peel right off. Look at that. You see, it's not melted in. That's why I can just peel it up. Look, I peeled that right up. So the problem is smearing is not enough. It's got to melt into the plastic underneath. And that is why I hold the soldering iron here and then I make a little groove. And then I kind of mix left, right, and notice the color change. And the reason I'm using the white is to show the color change. That's how I know that the melting is correct. See how it's going gray? Right, looking inside there, I'm showing that it's gray. It's mixed the donor plastic with the black plastic. Right, and just checking it. This is already really strong. I'm trying to break it and I can't. And I'm not even finished yet. Now, you can also get creative. You can use staples. Depending on the surface you've got, you could put a staple in there. And what you do is you heat up the staple with the soldering iron and it wedges in there. Now, in my case, I'm just going to do the finishing touches. There's a weak spot because, as you can see, if I pull this, it can start tearing there. So I want to build this corner up there and there so that it can't tear. And then also over here, this is also a weak spot. And on the inside here, I could just put a little bit more. Right, so I'm going to start with this section here. Right, so I first melt the part inside here. I make my grooves. And I'm not shy. I'm not going through the other side, but I'm making significant ridges here. And then I take my donor plastic and I melt it into that groove I've just created. Now notice that it's turned gray quite quickly because I made those grooves. So I lifted some of the plastic from the side. So some of the plastic from the side is now also getting in that groove and it has mixed with the donor plastic. Notice there is still a little bit of white there, so I'm just holding the soldering iron. I want it to get really hot. The key here is the heat. Now what just happened here is the plastic from here came out here and mixed with or melted together with the plastic on this side. Now that's going to make it much stronger. Here, right, so here's the cover and I'm just going to put that on. I'm actually perfect. Look at that. It's going to sit perfectly. It's not sitting above, so I can carry on with what I'm doing. Right, once it's built up, I let it cool down a bit and I take the soldering iron and I rub it. And by rubbing it, I'm smoothing it, getting it to the same level. Right, so I've built that up. That was completely missing and I just used a black cable tie. Right, so I'm finished the plastic welding. Now you could smooth it out, you could use a file, you could even use a Dremel and various bits, or you could just use sandpaper and just smooth out the plastic. You don't have to do this step, especially if it's going to be hidden from the user. But what I do recommend, if there's a place where it's going to seat onto another level, for example here, I can see that that's a little bit high. So I'm just taking my file and just making sure that the ridge here is even. Some of the plastic may deform some of these ridges and I'm just taking my file just to smooth it out. I want it to sit flush and there you can see that it will sit flush. Now, don't worry about all these scuffs and that's going to be hidden. And this part over here, yes, this will be in the view of the user. I did use the white plastic for explanation purposes, but I can just cut away the edges that I don't want the person to see. And sometimes what you can do is you can just take some black Koki and just go over the edge here so that if any of this is sticking out, it won't be an eyesore. Right, so there is the completed repair. This will be hidden and I just put on the cover. If in your case things don't seat properly, just cut away or melt away the parts that are in the way. And I'm showing I have a perfectly matching seam there, and on this side, even if I press it here, notice that that gap there is correct. So this is now ready to be installed on the vehicle, and I'm confident that this is stronger than the original. Right, so here's the unit which is now in the vehicle. Notice how rough I am. I'm literally yanking the car. And I can now put the cover on, and there's the repair. Notice on the top, we cannot see any of the plastic welding, and nothing on the underside either. And just to show you how strong this is, if you watch the front wheel, you'll see how hard I'm pulling on this door. And this is not going anywhere. And that is why I like the plastic welding. It's now stronger than the original. This is not the first time I've had to replace one of these, and that is why I did the plastic welding. It seems like the plastic welding is better than the original. Thanks for watching, and cheers.